Hi everyone, welcome to the fourth lesson for topic 2, Kinematics of Motions in Straight Line. So when you look at this learning outcome, you will realize that it is exactly the same with the previous lesson. Okay, so you can see it's the same thing like using the formula of for motion with constant acceleration, which is the force Hubbard formula that we have learned previously. Okay, so when we talk about the motion in a straight line, right, we talk about no matter it is in a horizontal plane or in a vertical plane, right? So in the previous lesson, the examples that we went through and the puzzle question that you try to solve are most likely to be a horizontal motion. So which means you see like a car move or either like a particle move and so on. All right. So today's lesson, we are going to look at the same thing, but we are going to apply it vertical motion. So meaning we are looking in the dimension of up, down now. All right. Okay, so let's start with the lesson. Alright, so this is a quick recap on what we have learned previously. Yeah, basically these are the Suva formula, right? So you know that each of these formula relates four of the variables. So like the first one without S, the second one without A, this one without V, and this one without T. Okay, so it will be depends on what variable you have and what is the variable that you wish to find. Then you decide which formula that you are going to use. So when you try to solve question by using all this formula, so one thing that very important is to fix where is your positive direction, then the opposite one will be negative. So you must make sure that when you deal with your S, your U, V, or even your A, so the sign of your variable is very important. All right. So for today's session is the notes part is actually pretty short. So just likely to be the recap. Then after that, a very short introduction, and we are going to look at for example. Okay. So what is more important is the application. All right. Right, let's start with the introduction. So this is about vertical motion. So there's a law called Galileo's law of free fall. All right, so yeah, this is, I mean, you don't need to remember the name of the law, but basically it's this guy named Galileo that found out this and he come up with this law. All right, so in the absence of air resistance, all objects in free fall. So let me try to explain this term a bit. So free fall basically referring to a motion of an object that falling down, and the only force that acts on this object is going to be the gravity. So which means it's not about someone pushing it, it's not about the wind blowing and so on. So the only force that going to affect the motion of the object is the gravity. So you can see the words in the absence of air resistance. Okay, so all objects in free fall will accelerate towards the ground at a constant rate. So in another words, right, meaning that all objects will have the same acceleration when they are in free fall. So it's independent of their mass also. So no matter how heavy or how light is the object, so as long as they are in free fall, so they are going to have the same acceleration. So all these cases, right, where the acceleration of the body is due to the gravity, the acceleration is widely referred as the gravitational acceleration. Okay, and the scientist has like found out this number, I mean the value of this acceleration, which we will try to write it in the short form of G, is equal to 9.8 meter per second square. All right, so this is the value that actually I think you guys use commonly in physics or in science. But when we talk about our Cambridge Maths exam, our question will expect us to use G is equal to 10. Okay, so yeah, it's for an easier calculation and so on. Like rather than using 9.8, we are using 10 for all the questions in the past year paper. All right. So next one we'll be looking at four examples. So it's going to be the similar thing like how we solved the previous question is by using Subat formula. But for today's question, it's all about a vertical motion. All right. So let's try to look at the example. All right, let's look at the example. So the first two example, it will be kind of easier. Then after that, the next two example is going to be much more challenging. Okay, so number one and two is just basically for your introduction. Okay, so number one, a ball is thrown vertically downwards from the top of the building. So you have a building that the ball is thrown down. So with a speed of 2.5 meter per second and the height of the building is 20 meter. So from this question, there are two information that is very obvious to us. The first one is that the initial speed is 2.5. Then the next one is that the height of the building is 20. So that's why we know that the displacement is going to be 20. So when we try to put our s as positive, right, meaning that we are referring to the direction of going down as positive. Okay, so you will realize that you only have two information and the question requires us to find the speed when the ball hits the ground, which means we are going to find the final acceleration, the final velocity. So we'll need one more information. So by having this, we know that it's going to be a vertical motion. So we know that the gravitational acceleration is going to be 10. Alright, so it will be the same in all the cases which involve vertical motion. Yeah, because if we talk about air resistance, then it will be involving like forces and so on already. Yeah, but in this chapter we are going to look at the motion itself. So we are assuming that all the vertical motion that we are looking at are without air resistance. So that's why the only forces the acceleration will just follow the the gravitational acceleration. Okay, so you can just write A or you can write G, is all alright. Okay, so by having USAV, so we can use the formula V square equal to U square plus 2AS. Okay, so since we are finding V, so we are just going to substitute everything in the right hand side. So plus 2 and then 10. So S is 20. Alright, so you will be able to get 406.25. And when you try to square root it, and you'll be able to get your answer 20.2 meter per second in three significant figure. Okay, so you must always make sure that only your last answer in three significant figure. But if let's say you are going to use this value in the next part, so please remember to write down your original value. So do not use the one that after rounding. Okay, so B, the time taken for the ball to reach the ground. So we have the similar information. So U is 2.5 and S is 20, and then A is 10, and then we want to find the T. Okay, so by having all this, then we can use the formula for S equal to UT plus half AT squared. Alright, so we can substitute the number, so 20 and then 2.5 T plus 1 over 210 T squared. So you try to arrange it and you will be able to get a quadratic equation, which is 5T squared plus 2.5T minus 20 equals to 0. So we can just divide everything by 2.5 and I will be able to get 2T squared plus T minus 8 equals to 0. Alright, and when you press your calculator, you'll realize that the answer that you get is going to be a number that you can round it into fractional form. So that's why we'll need to use the formula to help us to solve this. So T will be equal to, so negative B, negative 1 plus minus square root B square minus 4AC, so 1 square minus 4AC. Okay, and then divide by 2a, so divide by 2 multiply 2. Alright, so from here we'll be able to get two answers, which the first one is negative 2.266 and the second one is 1.766. So but because of this question we are finding the time, so that's why time should be a positive answer, so that's why time is going to be 1.766 seconds. Alright, so that's the part for number 1. I think it's pretty straightforward. So now let's try to look at number 2. Alright, number 2, a ball is thrown vertically upwards from ground level at a speed of 15 meter per second. So find the greatest height reached by this ball and also the time taken for the ball to return to the ground level. Okay, so let's start with A first. So the question wants us to find the greatest height reached by the ball, so which means that you can expect that you are actually finding the displacement. So some information that given from this question is that it's thrown upwards, so with a speed of 15 meter per second. So that's why our initial velocity is 15 meter per second. Okay, so yeah, sorry, I'm just going to write 15. All right, so since this is a motion that going upwards, so we know that for the gravitational acceleration, we are referring to a free fall. So that's why now our motion is going to be a negative one because of our direction is going to be the opposite. So that's why our A in this question will eventually become negative 10. Okay, then after that you'll realize that we have only two information, so that's not sufficient. So the question wants us to find the greatest height, so which means that when you are trying to throw the ball, so this is the place that the greatest height. So that's one thing that we know about this state, is that as long as that's the maximum height reached by the ball, that's the place that the ball change direction. So when the ball change direction, we will have our final velocity as 0. So that's the place that the ball reached the greatest height. All right, I hope that you still remember this idea from lesson 1. Okay, so now we are finding the S. Okay, so UAVS, so we can use the formula V squared equal to U squared plus 2AS. So we try to substitute the variable that we have. So 15 squared plus 2 negative 10 and then S. So from here we'll be able to get 20S is equal to 225. So I'll be able to solve S is equal to 11.25 meter. Okay, as simple as that. Okay, so B, so you're going to find the time where taken by the ball to reach the ground level. All right, so we can kind of using the same thing. So you see, what is the time for the ball to return to the ground level? So if this is the ground level, this is a place that we start, right? So at this place, our displacement is going to be 0 because it returns to the original place. So the displacement, meaning the net change in the position of the object, is basically 0. Okay, and the same thing here, we know that the initial velocity is 15 and the A is negative 10. All right, so from all this information, then we can find our T. So we need S, A, U, and T, so we can use the formula S is equal to UT plus 1 over 2 AT squared. All right, so substitute 0, 15t plus 1 over 2 negative 10t squared. So 5t squared, you are still getting a quadratic equation equal to 0. Okay, so am I doing anything wrong? Oh yeah, 15t. All right, so now we can try to factorize it. So take out 5t and I have 5 minus 3 inside. Okay, so I have t equals to 0 and also t equals to 3. So from here, which is my answer? Yeah, so to get an answer of t equals to 0, prove that what you are doing is correct. Because this ball is actually starting from the ground level. So that's why when t equals to 0, the s is supposed to be 0 as well. So that's why this proves that you are doing it right. So that's why the second time for the ball to reach the ground level will be when t equals to 3. Okay, so that's the idea. You cannot take t equals to 0 basically because of that's mean the beginning. So it's not the time where the ball returned to the ground. It's the time where the ball initially at, right? Okay, so that's the idea. So t equals to 3 seconds. All right, so now let's try to look at number 3. Alright, number 3. So this is a past year question from last year winter 2020 paper. Okay, so yeah, it's a pretty, I feel it's very challenging and it's good for us to go through before you attempt to your other past year question. So let's try to look at this question. Okay, so a particle is projected vertically upwards with a speed of 40 meters per second alongside a building of height h/cm. So let me try to draw this. So basically there's this building. Alright, so for this building, then after that, there's a particle here that is projected upward, so meaning it's being thrown up. Okay, and what happened is that given that the particle is above the level or in the top for the building for 4 seconds, so which means that when the particle is projected, right? So this moment, so which means as this is the top of the building, right? So the time when it go up and the time when it go down, this is the time when the particle is above the level for the top, right? So this part actually made up 4 seconds. Okay, so that's one thing that we can know is that you might want to remember that for vertical motion, right? Because we are talking about the same A, is just one A is -10 going up, then another A is 10 going down, and the displacement is the same. And then after that, you can actually guess that if let's say the acceleration is the same, right? So this is a place where the particle reaches the maximum height, right? So which the velocity here is eventually the same as well. So the starting to the final velocity at zero is going to be in the same magnitude when you try to change from zero to the final velocity when it reach here because of the same acceleration that we have. So because of all the variable is going to be the same, so that's why the time where it go up and the time where it goes down is actually the same as well. So which means that when I talk about it's going up and it's going down, right, the time where it reaches, if let's say the whole thing is going to be 20 seconds, so I know that going up spend 10 and going down spend 10. So it's going to be the same for all the situation. So that's why in this question, I know that for this 4 second, this particle is above the level. So which means it's from here until here, it takes up 4 seconds. So which means I know that from this point to this point is going to be 2 seconds. From this point to this point is going to be another 2 seconds. Okay, so now the question wants us to find the age. So what's the problem that we have here is that when I try to write down my information, right, then what do I have? The only thing that I have is the initial velocity is going to be 40. So it's a vertical motion, so that's why I know that the A will be -g in this case because of is this particle is moving up, right? So that's why it's -10. So that's these two information that I have. Then what else do I have? And I realized that I couldn't find anything about the height for the building because I do not have anything about this place, meaning I do not have what is the time that it reaches here, or what is the time that, or what is the displacement. That's the thing that we want to find, or what is the final velocity when I reach the top of this building. So what I need to do is that can I find the total time that this particle reaches the maximum height? I can, right? Because I know that at this maximum height, what happened here is that I know that my V will be always 0. So that's the thing that I only have. Okay, so we can do two approach here. The first one is by using to find what is our displacement. So you can imagine if let's say I know what is the displacement from here to here, right? Then later what can I do is after I get it, then I'll be able to use the U as 0. Then after that, when it go down, then I'll be able to find another S. Okay, so let us try to use this approach before I introduce the approach of time because we have 5 variable, right? So which means another one, we are going to use the time here. Okay, so now let's start with the first one first. So what am I finding is the total distance of this height and also above the height above the top of the building. Okay, so let us try to use the formula for v square equal to u square plus 2as. Okay, so v square is 0 square and then 40 square plus 2as. Okay, so I can get 20s will be equal to 16060, which will give my s is equal to 80 meter. So what does that mean? It means that from the maximum height until the ground, this thing is going to be 80 meter. Alright, so yeah, I can just try 80, I guess. Okay, so now let's try to look at how are we going to continue then. So we know that the whole thing is going to be 80 already. So how is that going to help us? So you realize that I'm still stuck here, right? I do not have enough information to tell me how, to tell, Okay, so obviously I cannot straight away find this because I do not have the time here, right? So I couldn't get my S. So now what can I do is I already get my 80. So do I have another approach, another alternative for me to get the displacement over here? So you can try to think about it first. So yeah, the idea is yes, we can. So what is the information we have? Is that we know that our initial velocity is going to be 0 if I'm trying to referring this place. So we know that going up take 2 seconds and going down take 2 seconds, right? So that's why the time is equal to 2. So the acceleration, because it's going down already, the acceleration is positive 10. So from here, I will be able to get enough variable for me to get what is my S. I hope that you understand what am I doing. So meaning that I'm only referring to this motion here. So which means at this place, I know that the initial velocity is 0 because it just reaches the maximum height. Then after that, it's going to take 2 seconds to reach this place, right? Then the acceleration, because it's falling down, is a free fall. So that's why it's can. So the idea is after we found the displacement here, then I'll be able to use 80 to minus the displacement here, then I'll be able to get the height of this building. Okay, so let's try to substitute to the equation of S equal to ut plus 1 over 2at squared. Alright, so S is the variable that we want to find. So 0, 2 plus 1 over 2S is A is 10, then after that T squared. Alright, so S, oh sorry, I think I have the T right. So it's supposed to be a 2 that, sorry, my cast mistake. Okay, yeah, so which means here I also have my T here, which is 2 squared. So from here, that I'll be able to get 4 half than 2. So I'll be able to get my S as 20 meter. So you might see that how come we do not have a negative here, because we are not looking both at the same cases. So you see, this is the thing where we didn't design that going up is all positive. So if in that the case, then we might get negative for this one. But we are looking at this as a new motion. So that's why this is your starting point. So it's just treating our going down as positive. So that's fine as well. Okay. So after we get our answer, then now we can continue then by minusing our answer. So which means the height for this question is going to be the displacement 80 minus 20. Then I'll be able to get 60 meter. Okay, so that's the first approach. Okay, so now the second approach is like what I mentioned just now by using the time approach. So how we can do that? So we have the similar information here. So initial velocity, the acceleration, and the v is equal to 0. So that's why my s, oh sorry, in this case then, which means I'm finding my t lah. Alright, so what am I doing is I want to find what is the time from the beginning to the to the time where the particle reaches the maximum height. Because by finding the total time, then minus 4, then I'll be able to get the time for here. Okay, so meaning now I can use the formula of v equal to u plus at. So substitute 0 and then 40 plus negative 10 and then t. So by having this, then I'll be able to get 10t is equal to 40. So that's why t is going to be 4 seconds. So we already know that the time from this place to this place is going to be 2 seconds, and from here to here is 2 seconds, right? So if this one takes up 2 seconds, which means from here to here is going to be another 2 seconds, because the total time for this particle to reach the maximum height in total is 4 seconds. So that's why the time, so I can just write the particle reaches the top, right? Reaches the top of the building before it goes beyond the top of the building. Reaches the top of the building when t equals to 2. Okay, so I hope that you get what I mean. So it's basically by using 4 seconds that minus the 2 seconds that we know from this point to this point. So that's why this is how I get 2 seconds. So by having this, then I have another new variable here, which I can always use t equals to 2, then u is 40, the initial velocity, and with the a -10, then I will be able to get my s. Okay, so yeah, this is pretty easy. So s equal to ut plus 1 over 2at squared. So substitute all the information that I have. So 40 multiplied 2 plus 1 over 2 multiplied -10, then 2 squared. Okay, so from here 80 minus 20, then I'll be able to get 60 meter. So you see, it's going to give me the exactly same answer. All right, so now let's try to look at part B. Alright, so let's try to look at part B. So this question is a bit similar like the last example that we have in the previous lesson. So if let's say you feel that it's challenging to try yourself, then please feel free to do so. Then after that, you check video for the answer. Okay, so 1 second after the first particle is projected, the second particle is projected vertically upwards from the top of the building with speed of 20 meters per second. Okay, so if let's say I'm going to draw this out, right, how is that going to look like is that, let me try to draw this. Okay, so this is the ground, right? Then I know that there is a building here, which I already found out the height of this building is going to be 60 meter already. Okay, so what happened here is I have my first particle is on the ground, then after that is projected going up. Okay, so now what happened is this is when t equals to 0, right? Then after that, when t equals to 1, what happened is I have my second particle here and it's going to project it up as well. But the difference between here is that you can see that the second particle is projected vertically upwards from the top of the building. So that's why our drawing, the particle shouldn't start at here. So it should be from the top of the building, so which means it starts here. Then after that, it's projected up as well. So this question wants us to find what is the time where the two particles are at the same height, which means what is the time if let's say both of them reach here. Okay, so yeah, I hope that you still have some idea of how we solved this in the previous lesson. So which means the only thing that we have in common is that we need to get the displacement in common. Yeah, so that's the idea. Okay, so the first thing is to find out the displacement maybe. So we know that this is going to be our S1, right, for the first particle, and this is going to be for our S2. So for this question, it's even much more obvious that your S1 and S2 cannot be the same, because for the previous lesson, we talked about like the two particle, they are moving towards each other, but this one, they are actually moving towards the same direction. So obviously you do not have S1 equal to S2. And because of when we talk about displacement, right, we are referring to the different origin point. So if let's say S2 also start here, then which means they have the same displacement, that's correct. But for here, your S1, the reference point is here. Your S2, the reference point here is here. So that's why their S1 and S2 cannot be the same in this case. So what is the relationship between S1 and S2 then? So you can try to imagine, if let's say I try to get S1 as 100 here, then what would be my S2? My S2 will be 40, right? Because eventually it starts here. So when the both of the particle is at this point where it give 100, uh, which which will give S1 as 100, which it will give S2 as 40, because the reference point is here. So that's why the first information that I have is that my S2 is going to be equal to my what I get for my S1, then after that minus 60. Because if S1 is 100, then I know that my S2 will be 40. So that's the idea. Okay, so this will eventually become my first equation. So now I'll continue to get for the first particle. Alright, so perhaps I need to use left and right because I worry that I do not have enough space here. Okay, so for first particle, okay, so what is the information that I have? So I have the initial velocity, right, which what is given in part A. Yeah, so this are the information. So which I know that U is actually equal to 40 and A is -10. and then the s and t is the one that I wish to solve it out lah. So which means in this case, then involve s, then I might need to use the formula of s equal to ut plus 1 over 2at squared. Alright, so I can get 40, and then t is the time, then plus 1 over 2a negative 10, and then t squared. So for this case, this is S1 lah. So this is how I get my first formula. S1 is equal to 40t minus 5t squared. Alright, so that's for the first one. So now let's try to look at for the second particle then. Okay, so for the second particle, what is the initial velocity? It also has been given in this question, right? So which our initial velocity is actually 20. Okay, so it's moving upwards as well, so that's why my a is going to be negative 10 as well. Okay, so now I have a problem. How about the time? Is the time for second particle is going to be t as well? Okay, so you might want to remember this because the second particle is actually projected 1 second after the first particle is projected. So which means when for the first particle, when t equals to 1, then only the second particle start t equals to 0. So that's why if later I were to equate the two equations together, so which means that what I can try to, okay, let me try to write it in a much more clearer way, which in this case is going to be t1. So this is basically the t that we want to find lah, because the t in this question is referring to the time after projection of the first particle. So that's why in this case for the second particle, right, we have our t2. And what is the relationship for t2 and t1? So our t2 here, so you can imagine when first particle is t equals to 1, then second particle is t equals to 0. So which means t2, it will be 1 second lesser than t1. So this is going to be my equation as well. Okay, so now I'm going to substitute. So as I am using the exactly same thing, so I can just do S2 is equal to U T2 plus 1 over 2A then T2 squared. Okay, so which in this case I'm finding my S2, so I can straight away substitute in. So putting in 1, so this is my third, so this can be my fourth lah. So I can straight away substitute everything, so 1 and 2, and also all the information that I substitute into 4. So S2 is S1 minus 60, right? So S1 minus 60. Don't worry, if let's say you want to substitute your U and A first, then only you substitute your 1 and 2 also can. It's just going to be the same. Yeah. So U is 20, and I know that my T2 is going to be T1 minus 1, so T1 minus 1, and then plus 1 over 2, and the A is negative 10, and T2 is T1 minus 1, then squared. Okay, so if let's say you just want to put a normal t here, then you must remember here also put a normal t lah. Yeah, the idea is you must make sure that you understand the variable that you are trying to put in. So S1 minus 60, it will be equal to 20 T1 minus 20 minus 5. Then let me try to expand this first. So I'll be able to get T1 square minus 2T1 plus 1. So after I expand, then I can get S1 minus 60. Let's try to do step by step. So negative 5T1 square, and then plus 10. So that's y plus 30T1 minus 20, and then minus 5. So minus 25. Okay, so simplify, then I can get S1 will be equal to negative 5T square minus 30T minus 35. Okay, so this is what I can get out from here. So 1T1, T1. So this will be my fourth equation. Sorry, I have fourth already, so this is supposed to be my fifth here. Alright, so after I get this already, then I'll be able to just equate number 3 and number 5 together, right? So 3 is equal to 5. So that's why 40 T1 minus 5T1 square is equal to negative 5T1 square minus 30 t1 minus 35. Okay, so this negative 5t square, negative 5t square, so you don't have any more. So try to bring this over the other side. I'm sorry, is this plus? Oh yeah, sorry, this is supposed to be plus. All right, so here is plus. So when I try to bring this over here, then I'll be able to get 10t, then equal to 35. Okay, I'm sorry, this is supposed to be plus. What am I doing? Yeah, sorry. So S1 then plus and then negative 25 plus 60. Yeah, so plus 35. Sorry, my mistake. Okay, so yeah, because I know that my t shouldn't be getting a negative answer. So 35, so that's why I know that my answer is t equal to 3.5 seconds. Okay, so that's the idea. All right, so let's try to look at the last example. So I hope that you can understand this question. If let's say you got any question, that let me know again. Yeah, but basically you are finding the value of t, and you have one similar question in your past year exercise as well. All right, so now let's try to look at the last example. All right, number 4. So this is a question from past year paper from winter 2018, 17 also. So I find this question quite interesting. So I think we can try to discuss here together because from the marking kit itself, it's only given your answer because it's most likely to be like the B1 mark. So it's not so much about the methods or the formula, especially for part B. So it's more on you try to understand the situation that's given here, then you can state your answer, then you can get the marks already. All right, so let's try to look at A first. So a particle is projected vertically upwards from a horizontal ground with a speed of 12 meters per second. So find the time taken for P to return to the ground. All right, so this particle is projected upwards, right, with a speed of 12. So which means that from here, then we can try to uh, design that the positive direction will be going up lah. All right, so we have the speed, which is the initial velocity as 12 meter per second. Then after that, since we know that it's a vertical motion, so the A here is going to be negative 10 as well. Okay, because it's going upwards. Then after that, we want to get our time for the P to return to the ground. So that's why back to the ground, then the displacement has no change. So that's why S equals to 0. So the time we want to find, so which is T. All right, so U, A, S, and T, then we can try to use the formula of S equal to UT plus 1 over 2AT square. So let's substitute. So 0 is equal to 12, and then T minus 1 over 2A and T square. All right, so now we can try to get our answer for t. So I will have 5t square minus 12t equals to 0. So it's a quadratic also. So take out t, then I have 5t minus 12. So I'll be able to get my answer, which t is equal to 0 or t is equal to 2.4. All right, so in this case, when I try to check, then I will be able to know that because when we talk about s equals to 0, which means it returns to the original position. So that's why when t equals to 0, the s is at 0 as well. But in this question, our t must be a number that is not the initial, right? So that's why our t will be 2.4 seconds. Okay, so that's the part for A. I think for this one is quite simple. So now let's try to look at the B. Okay, so it's given that the time in seconds after P is projected is denoted by T. So when T equals to 1, a second particle Q is projected vertical upwards with speed 10 meter per second from a point which is 5 meter above the ground. So the question wants us to find the so the particle P and Q, they move in different vertical lines. So which means that maybe when one going down, the other one is already going down and so on. So for the question of B, they want us to find the set of the value of time where the two particles are moving in the same direction. So which means what is the time range that both of these particles is moving up, or what is the time range that both of these particles is moving down. All right, so that's the idea. So for an easier work, right, then what we can try to do is we try to get what is the timing for P to go down and to come down, and what is the timing for Q to go up and come down. All right, so let's start with P. Okay, so you can see that for A, right, the t here, when the time taken for P to return to the ground is 2.4. So can you try to imagine what happened here is that you have an object. So you are throwing it up, then after that it moves down. So the whole process actually take 2.4 seconds. So do you able to actually find what is the time when the ball is here? So which mean that, sorry, when the particle is here, so which mean that that's the critical time where you know that it's going up and down. So as what I explained in the question 3, so because of you can imagine that this, okay, so they have a initial velocity, then when you have the same so is the motion is going to be affected by the gravitational acceleration, right? Then after that the velocity actually decreasing until zero, then after that in the other way around, right, is going to affected by the gravitational acceleration as well, but in opposite direction, and it will reaches back the same velocity over here. I hope that you get what I mean. So because of the same is the difference is just because of the opposite direction. So that cause your V and A to be positive and then after that become negative because of the change in direction. So that's why when you have the motion that up and then go down, right, the critical point would just be half of it. So meaning that 2.4 seconds for the whole process, and it's definitely going to be 1.2 going up and 1.2 going down. So that's why the critical point, okay, for this first particle is actually at for particle for P lah, okay, so it's going to be at T equals to 1.2. So the idea is when it's going down, it takes 1.2 seconds. Going down, take another 1.2 seconds. So that's the idea. So if we try to write in the time range, right, so meaning that when it's going up, it's actually from the time t equals to 0 until t equals to 1.2. Then after that, it goes down, and when it reach the ground, it's going to be t equals to 2.4. So that's the idea. So we are going to do the exactly same thing for the critical point for Q. So let's try to see the information given for particle Q. So for particle Q is the particle is only projected when t equals to 0, meaning 1 second after after particle P is projected, then only particle Q is projected. Alright, so it's vertically upwards with a speed of 10 meter per second as well. So that's why it's going up first, then after that going down as well. Then, but it's from a point which is 5 meter above the ground. So now we want to find the critical point for Q. How are we going to do that? Okay, so my question to you is there are two. So do you think that we need to change our t to be like t minus 1? Because eventually the time for the first second in particle Q in particle P is going to be the 0 second for particle Q, right? Because it's projected 1 second later than that. So do we need to do t minus 1? So that's the first question. Then the second one is, do you think we need to change our displacement to be either s plus 5 or s minus 5? So to indicate that our reference point is actually 5 meter above the ground. So do you think that you need to do so? So we are just only talking about to find the critical point for particle Q. So maybe you can pause the video and try to think about it before you continue the video. Yeah. Alright, okay. So the idea is that you do not need to do so. So you must remember that when we try to talk about displacement, we are always referring to our initial point. So if let's say the initial point for P, okay, so let me try to draw this. So the idea is that you have this ground, right? So this is where P started. Then after that, when you try to project the Q, is actually started from here, and the distance between here, which P started and Q started. So the difference here is 5 meter. But when you try to when we try to find the critical point, right, isn't it you are referring to this point as well? So for Q, this is the 0. It doesn't matter whether P starts at here or start at here, because in this question, we are not going to compare, we are not going to equate the equation like what we have done in number 3. We are just going to look at what is the pathway for P and what is the pathway of Q. Then we try to see what is the set of value that these two particles are moving in the same direction. So that's why for Q, right, at this place, the S is 0. And when it come back to this place, it's still going to be 0. We are just going to build an equation for Q only. So that's why the 5 meter here actually doesn't matter. Okay, so I hope that you can understand what I meant here. So basically for this one, so which means that now I have this particle. So it's going up, then after that going down as well. Okay, so I want to, and I also have what is that called? So in this question, I will need to find out my t by myself, right? So, but a few things that I have here is I'm given the u, so which means the initial velocity, which is given by 10 meter per second. And similar to how we do number A, so I also have my gravitational acceleration, which is negative 10. Okay, then after that, we are finding when the time or the total time, like how we find A, so we get this time, then after that we divide by 2, right? So that's why it's going to be the same thing. So we are going to find what is the time where the particle Q goes back to the original position. So when S equal to 0 and we want to get the time. Okay, so we can use the same formula, which is S equal to UT plus 1 over 2AT squared. So from here, then I can get 0 equal to 10t plus 1 over 2a and then t squared. All right, so from here, then I'll be able to get 5t squared minus 10t equals to 0, which will give me the t of 2 value as well. Sorry, let me try to 5t, and then I'll be able to get t and minus 2. Okay, so that's what I can get it. All right, so from here, I also can get two answers, right? So which means the first one, it will be t equals to 0, which proves that what I'm doing is correct. Then after that one, t equals to 2. So which means the critical point for particle Q, is it going to be 2? Yeah, so you must remember 2 is when it's come down. So that's why the whole process takes 2 seconds. So the critical point when Q change direction is going to be T equal to 1. Okay, basically 2 divided by 2 lah. So we know that when it goes up, is from t equals to 0 until t equals to 1. Then after that, it falls down and t equals to 2 come back. Okay, so now we are going to find what is the time where the two particles moving in the same direction. But move on, you might want to recall that in this question, this second particle is actually projected 1 second 1 second slower than particle P. So that's why we might need to change this diagram into the taking the consideration of it's 1 minute later. So you can imagine when t equals to 1, when particle Q first projected is actually equals to t equals to 1. Because the t that we are going to find, right, is going to referring to the time where p is projected. So when q is projected, it's actually t equals to 1 already. So it spent 1 minute to reach the top, so that's why it's going to be t equals to 2 here. And when it's going down, it's t equal to 3. Okay, so now we can try to look at these two diagrams that we have, then we try to find out where's the time that these two particles is moving in the same place. Okay, so let's try to look at going up. So when it's going up, it's from 0 to 1.2 seconds for particle Q, and it's from 1 to 2 seconds for particle, sorry, it's 0 to 1.2 seconds for particle P, and it's 1 to 2 seconds for particle Q. So that's why the time range that they have in common is only from 1 minute, from 1 second to 1.2 seconds. Because from 0 to 1, Q is not even projected yet. So for the time where they are in the same direction, the first one that we have is when the both particle going up. So it's in the range of the time from 1 until 1.2. Okay, so that's our first answer. It's when both of them is going up. Okay, so now let's try to see going down. So for particle P, the time where particle P is going down is from 1.2 to 2.4. Then for particle Q, it's 2 to 3. So what is the common time here? is going to be 2 to 2.4, right? So that's why the other one is going down, is going from 2 second to 2.4 second. Okay, so this question actually the marking key you'll be only given the marks when you try to state the critical point here. So which means you understand that it takes 1.2 going up, 1.2 going down. So this is 1 mark. After that, the second one, it will be like what you have over here. Yeah, so to get the 2 second, after that to realize the critical point for Q is 1 second. So that's second point. After that, 1, 2. So that's the 4 point for this question. So basically for this question is the B marks. So meaning that the marks is based on what you state, is not so much about the method or the formula. Okay, so it's basically about the statement of what you have written. Alright, so that's the part for the questions. So I hope that you can try to spend some time to understand it. Then remember to finish your past year question homework as well. Alright, so that's it for today's lesson. Thank you.